It's coming on time for the kids to take their Unit 2B summative test, and this is just a review to help them prepare for it. The test is really just on estimating with decimals and multiplying and dividing decimals, but one of the trickier parts about taking this test is going to be knowing what to do for each of the questions. So, for number 1, in class, what I'm asking the kids to do is I will ask them whether it's a question that wants an estimate or an exact answer, and then I'll ask them whether it's addition, subtraction, multiplication, or division. And I'll have them stand when they hear the one that they think is correct. Get a little movement going in the room. So for the first one, Tyler buys 3 snacks at the gas station: Doritos for $2.19, gum for 85 cents, a giant Hershey bar for $4.99. About how much did he spend? So the first question is it estimation or an exact answer? And you see the word about here. And about is a keyword that tells us that we need to estimate. So our answer is going to be an estimate, not exact. And then we need to figure out what we need to do. Well, he buys 3 things and we want to know what he spent. So we have to put those things together to get how much he spent. So that's an addition problem. So that's about $2 plus about $1 plus about $5 is equal to about $8. Sorry. For number 2, Leslie walks 25 miles per week. How many weeks will it take her to walk 350 miles? So there's no about in this question. They want to know exactly how many weeks. So this is definitely an exact answer question. And we have both of our units here are miles, and we want to know the time. How many weeks will it take her to walk a total of 350 miles? If you could put a total of in there, then it's a good sign that it's probably a division problem. This is division, because we have the total miles and we have the miles per week, and we want to know, well, how many weeks? So the miles per week times the number of weeks equals the total miles, or the total miles divided by the miles per week equals the number of weeks. So this is 350 divided by 25. So 25 doesn't go into 3, but it does go into 35 one time. 1 times 25 is 25. With 10 left over, bring down the 0, and we get 100. 25 goes into 100 4 times exactly. And voila, 14 weeks. So that's the second one. 3, Haley purchased 4 cakes that cost $12.95 each. About how much money did Haley spend on the cakes? So about tells us that we need to estimate. She purchased 4 cakes that cost $12.95 each. Each is a multiplication or division keyword, but it could be either one depending on the context of the problem. So Haley purchased 4 cakes, and each of them was $12.95. So you got to think, well, 1 is $12.95. How much for 4? So we're multiplying by 4. So this is a multiplication problem. Multiplication. And it's about $13 times 4. So your answer is going to be about 13 times 4, or $52. But really, you could have also estimated about 10 times 4 is 40, would have been an acceptable estimate, or even 15 times 4 is 60, would have been an acceptable estimate. It depends on what your answer choices are and how close to the exact you need to be in order to pick out of your answer choices. 4, Allie makes bracelets that use 34 beads. She has 1,482 beads in her kit. How many bracelets can she make? So this is an exact answer. We want to know how many bracelets she can make. We know how many total beads she has, and we know how many beads it takes to make one bracelet. But we don't know how many bracelets she can make. So this times the number of bracelets she makes should be the total number of beads, or it's a division problem. Total number of beads divided by beads per bracelet equals the number of bracelets. Divided by 34. So I actually use estimation to help me here. I say, well, if this is close to 30, and 30 times 4 would be 120, which is slightly less than this. And 30 times 5 would be 150, so I know this can't be 5, so it's probably 4. So I'm going to go ahead and try 4 up here and see if 34 goes into 148 4 times. So I try my multiplication step, and I get 16, that's 12, that's 13, 136, which I can't fit another 34, so that's pretty good. I subtract and I get 12 left over, bring down the 2. Now I can't get another 4 out of there, but I can get 3 out of there. Let's see how many that would be. It's 12, 9, 10, 102. Now, there is a remainder of 20 beads left over, but she can only actually make 43 bracelets, so the answer is 43 bracelets. The remainder doesn't actually matter because they don't ask about the remainder in this problem. Number 5, Barney spent $5.34 on 6 cookies for his friends at lunch. How much was each cookie? Okay, well this is an exact problem. And each implies multiplication or division. And each in the question, how much was each, implies division. How much for one? Which means you know how much for many, you want to know how much for one. So it's 534 for 6, how much for 1? That means it's 534 divided by 6. How much for 1? So 6 doesn't go into 5, but it goes into 53 8 times, which is 48, with 5 left over. Bring down that 4, and 6 goes into 54 9 times, exactly. So our answer is 89 cents. Number 6, Larissa uses 7.8 inches of string to make a bracelet. She makes 12 bracelets. How much string does she use? This is an exact answer. And it doesn't say each, but I can replace this with each. So this is a multiplication or division problem. Basically, all the bracelets are the same amount of string, and she makes 12 of them. So how much total string does she use? This is a multiplication problem. Because we know how many, we know how much of each, we want to know how much for all. So that's 7.8 times 12. I'm going to use lattice because there's a neat trick with lattice that I feel is worth sharing for anybody that uses lattice. It deals with the decimals. I should have made that bigger, but we'll get the idea. 2 times 8 is 16. 8 times 1 is 8. 7 times 1 is 7. And 7 times 2 is 14. Then I add along my diagonals. This is a 6. This is 13. This is 9. So the digits in my answer are 9, 3, 6, and I just need to place that decimal. So it's harder with this one, but if you place the decimal in a whole number, it's always at the end of the number. So what happens with decimals and lattice is cool is that wherever the decimals line up on these lines, you make a cross and then go down that diagonal line, and that's where the decimal goes in the answer. So it goes right here, 93.6. I can also check that with my estimate. If I make an estimate, it's 7.8 times 12. That's about 8 times 12, which is about 96. So that's close to 96. And also there's 1 decimal place, so there should be 1 decimal place. So it's 93.6 inches of string to make 12 bracelets. Number 7, simplify. In most cases, if you just have numbers, simplify means solve. What simplify actually means is get to the smallest amount of terms possible. And in this case, we have 2 terms right now, and if we multiply them, which is what parentheses means, then we'll only have 1 term. So that's simpler because there's fewer terms. So I'm going to set up lattice again, so you can see that decimal point in action again. It's 3.54 times 5.3. So this is what my lattice looks like. Make my diagonal lines through it. It's interesting because they automatically line up the place values. This is my 3 times 4 is 12. 5 times 4 is 20. 5 times 5 is 25. 5 times 3 is 15. 3 times 3 is 9. And 5 times 3 is 15. Add on my diagonals. 2, 6. That would be 10, 17. Carry the 1. That would be 3, 8. And a 1. So my digits are 1, 8, 7, 6, 2. Now I can place my decimal by estimating. It's about 15 or 20. Between 15 and 20. So 18 point something makes the most sense. Or I can use that trick with the lattice where the decimals meet. This is if I go across, this is where they meet, and then I follow that diagonal line down. Decimal goes right here. 18.762, 18.762. And also 1, 2, 3 decimal places, 1, 2, 3 decimal places. Alright, again, simplify means solve. This is division. First term goes inside the house. So it's 35.91 divided by 3. 3 goes into 3 one time. It goes into 5 one time. Notice I knew 3 minus 3 would be 0, so I just went ahead and skipped that step. I could also say 3 goes into 35 11 times, which is 33, and then subtract. Get 2 left over, bring down this 9. 3 goes into 29 9 times, which is 27. 2 left over, bring the 1 down. 3 goes into 21 7 times, which is 21, and I can stop. And it's about 36 divided by 3, so it should be around 12, so 11.97 makes sense, and it brought the decimal right up the way it should, so 11.97. Jose earns $15.25 per hour. Per is a multiplication division keyword. He worked 2.5 hours on Saturday. How much money did Jose earn on Saturday? So this is an exact answer because it's not saying about. It wants to know how much did he earn. So he worked 2.5 hours and it's $15.25 per hour. So I know for 1, I want to know for 2.5. I want to know for more, so I want to know multiplication. So it's 15.25 times 2.5. So I can set it up on a lattice again. I kind of go back and forth between what method I like the most in these videos. For a while I was using grid. But right now this one just seems like it works really well. This is a decimal and this is a decimal. So my decimal should come out over here, theoretically. Because that's where they would line up. I also know that this is about 15 times 3, so it should be around 45. So 5 times 2 is 10. 2 times 2 is 4. 5 times 2 is 10. And 2 times 1 is 2. 1 times 5 is 5. 5 times 5 is 25. 2 times 5 is 10. And 5 times 5 is 25. So that's 5, 2, and nothing is 2. 5, 1, 4, and 1 is 11. 1 and nothing, and 2 and 5 is 8. And 2 and 1 is 3, and there's nothing there. So it's 38.125, which is kind of close to 45, so that makes sense. Oh, and the reason that it's because we're talking money, how much money did he make? So you can't make $38 and 125 thousandths. So what you do is you cut off just the money part, but then you use the leftover to tell you should you round up or down. Should you round up or should you let it go? And 5, this says round up, so you round up to 38.13. Bam. 10. The cafeteria uses about, keyword, 97 hundredths of a gram of salt to season 368 burgers. About how much salt is used to season the burgers. This question is not very specific. More accurately, it would read 97 hundredths of a gram per burger to season 368 burgers. How much total salt is used? So, per burger, finding a total, that's multiplication, and it's estimation, because it's about. So this is about 1, and this is 368 times 1 is 368. About 368 grams. A little less, because this is a little less than 1. Oh, and there's one just like this on the test. And all you gotta do is remember, if you round to 1, this is a really easy problem. Alright, write a problem you would use to mentally estimate the following. So if we're trying to mentally estimate and we're just writing a problem, we don't need to answer it, we just need to write it. So I would round this personally to 320 divided by 10. Because if I wanted to solve this mentally, that would be the easiest to me. So if I round to 320 to the nearest tens place for both of them, 320 divided by 10 is not hard. I can answer it. It's 32. You could also round to 320 divided by 12, but that's not as easy to solve mentally. Or you could do 300 divided by 10. So there's lots of choices here. 300 divided by 10. Lots of choices. Pick one. A went shopping to purchase 2 video games that cost $9.99 each. He has $35 to spend. About how much money will A have left after purchasing the 2 video games? This is a 2-step problem because he has 2 games that cost this much, and we want to know how much will he have left. So not how much will he spend, but how much will he have left. So first, let's figure out about how much does he spend. Well, this is about $10 times 2, or 10 plus 10. Which is about 20, is about how much he spent. But then I want to know how much he has left. So that's, he has $35 to spend. $35 to spend minus $20 spent is about $15. So it should be around $15. And that should be it for that. Next video is going to be going over the homework. Which has the answers for the kids. I don't want it to be hard for them. I want it to prepare them for the test. So